Hi again, students. We are going to talk more about electricity. And so right now we're going to use Ohm's law with two different types of circuits. So this one is going to be about different types of circuits. There are series circuits and parallel circuits. We want to know the difference between each of those and how to use Ohm's law with those particular circuits with their particular rules. So a series circuit is the most simple one that we can have. And
okay,
so
I found this.
Siri's trying to help us out. Siri heard series. A series circuit has one path for current to travel. It's like old Christmas tree lights. If you've ever dealt with those, and one goes out and then they all go out because they have only one path to travel. And if the path gets broken, then the current can't flow. It doesn't have anywhere else that it can go. And so what you are seeing there is a circuit diagram. And so to draw and let you see a little of what those different parts mean. That symbol means battery, and it kind of just shows us the branches that are connecting out. This symbol means resistor. It can stand for a light bulb or anything else, and it shows that you have just the one path. If there's a switch, it could be represented like that. And so we can see that there's only one path to go. If the switch is open, then it's not going anywhere. So houses are wired in series circuits because you flip off the switch to the light in your bedroom, then the light's going to go off because that one switch made the connection either complete or made it broken. And so if it's broken, no electricity flows. So battery provides voltage. We'll always care about voltage right here. Resistance, some amount of ohms with each resistor, and current is flowing, okay? Current is flowing. And so we kind of need to see the different rules that apply with each of that, but I just wanted you to see a series circuit. And so this is one of the simplest series circuits that I could plug up. And so this battery holder actually has a switch of its own. And so we have a wire connecting from the battery holder to one end here. And we're going to connect the other wire. And it's not working yet because the switch is closed. And so hopefully you can see the light bulb is shining. Though maybe with the light bulb you can see it a little better. So the series circuit. Now, if I break just that spot, so what I did was it was connected and now it's not. I broke that one spot, and so there is no longer a way for the current to travel. So it doesn't. And so that's a series circuit. Now we could rearrange this and let it have two pieces. So we're going to try to do that. And we want to be able to follow the path of the electricity. All right, and so we're going to have two light bulbs in that one, and I'm going to let this stick out just like the other so they look the same. Okay, the switch is still down, and we're connecting them. And so we can make some observations. Number one, electricity is coming in through here, here, and back out. The circuit is complete. Like Christmas lights, if one of these doesn't work, then none of them work. Or I just threw it away testing them, but like I said, that's old Christmas tree lights. That's the point. And so this is a bulb that was broken because it didn't light. So even though it's in there, there is a connection that's not working within this bulb, and therefore neither bulb lights, even though we know that this one is good. The connection is broken, and that's the main important thing about a series circuit. Also, we can look and we can notice that there's a definite difference in brightness here. And so What's happening, what we'll see in a minute, is that the voltage that's within this battery is being shared between these. And so this voltage plus whatever's in here adds to equal whatever's right here. All right, and the other thing about a series circuit is that since there's one path of travel, we think of current like water flow, and so there's only one path. And so if you've got, think of it like a lazy river. Okay, if you've ever been in a water park in a lazy river, unless you mess with some height or you start narrowing the path or something, if it's all just the same, then the water flow is going to be the same. So the current in each part of these circuits is the same. But if there's a different resistance here, then there could be a different voltage here, and that voltage is shared. So we'll go ahead and look at a series circuit problem, just saying that in a series, since there's only one path for current to travel, current is the same in every part. So the voltages have to add to equal the total. And the resistances have to add to equal the total. Okay? And so one problem with this that you will have, so looking here at part B, I'm going to turn the lights back on so maybe we can see better. All right, and those are just kind of small, so I'm just going to redraw it on this board. B part of this worksheet in your packet, we've got the battery symbol. We can tell it's a series because there's only one path. And this one says 2 ohms and this one says 5 ohms. And so in a series circuit, the resistances add, so the total resistance is just those two combined. The total resistance is 7 ohms. In this one, it didn't say, but let's say that we had 10 volts for the voltage, then that's the total voltage. Then we could find the total current by using Ohm's law. Ohm's law is V equals IR. And we know a total voltage. And we know a total resistance. And we can find the total current. And so we would divide. And if we wanted decimals, then about 1.4 amps. Okay, and the important point about that is that current stays the same. So there are 1.4 amps everywhere along this circuit. This resistor, this light bulb is experiencing 1.4 amps, and so is this one. So we do the totals. We start with the totals, and then we can find some individual things that are happening. Like we said that voltage is shared between things. So we're going to work a problem in a minute that's a little harder that goes into more of that. All right, so a series circuit, number one, if any part of it breaks, all of it breaks. Current is the same, therefore voltages add together and resistances add together. So we're going to go ahead and work that harder problem with a series circuit, and then we're going to make another video for parallel. So series circuit right here on this worksheet. You've got the sheet. But it tells us that R1 has a resistance of 10, and R2 has a resistance of 20, and R3 has a resistance of 30 ohms. And it told us that we had a total of 6 volts. And so what it's doing is it's asking us R1, R2, R3. It's asking us what we know for each of them, and then for the total. And so for voltage and for current and for resistance. All right, that's on your sheet. It's just real hard to see here. And so if the total voltage is 6, well, what we know is that this plus this plus this had better add to be 6 when we get all said and done. We know that total resistance comes from adding the resistances of each of these pieces. So we should just say 10 plus 20 plus 30. And so we have a total resistance of 60 ohms. Well, what we just did was use the total resistance and the total voltage to find the total current. And so we can do that with Ohm's law. Since V equals IR, and we know that the total voltage is 6, and we're looking for the current, then we're going to solve for current and find that it's 0.1 amps. So, since this is a series circuit, and this is the important point, since in a series circuit the current is the same everywhere, if we've got 0.1 amps, then we have 0.1 amps in every one of these pieces. So the first thing we do is find the total resistance and use that with the total voltage to find the total current. We already knew that resistor 1 had a resistance of 10 ohms. And so now we could find the individual voltage that goes through that individual resistor. And so we'll just use Ohm's law again. And so we're just knowing different stuff. We just don't know the individual voltage that's in this individual resistor. And so my voltage is going to be equal to my current times my resistance, 0.1 times 10. Well, that's going to give me 1 volt. I want to do that again for resistor 2. I've still got 1 amp, but this time I've got 20 ohms of resistance. And so I'm going to end up with a voltage of 2 volts. And then to do this for my third resistor, I've got 30 ohms. I've still got a current of 1 amp, and so I have 3 volts going through that. And what makes me really happy about that is that this plus this plus this equals 6, which I knew had to be true based on the rules that were given to me. Okay, and those rules exist because since there's only one path to travel, current has to be the same everywhere. Resistance adds together and voltage adds together. And so we've seen a series circuit. We've seen that if one part breaks, the whole thing loses power. And so the next video will have parallel, and I'll see you later.